for the sake of time, we've got a few people jumping on now, so we'll go ahead and get started. I want to welcome everyone to the Engineering and Operations Management Lunch and Learn webinar series here at the University of Arkansas. We are in the College of Engineering in the Industrial Engineering Department. We have 3 Master of Science programs with Operations Management, Engineering Management, and Engineering. We also offer 3 graduate certificates in Project Management, Lean Six Sigma, and Homeland Security. And we'll cover these programs later on in the presentation and be happy to answer any questions you might have. So welcome, my name is Karen Hickenbotham. I'm in Marketing Communications in the Operations Management and Engineering Management programs. Please save all questions until the end of the presentation. And those questions are going to be typed in the chat box at the end. We want to let everyone know that this webinar is being recorded and will be posted on our ScholarWorks at UARC collection in the U of A library system, in our operations management collection that you can also view. So I want to thank everyone again for joining us today, and we'll go ahead and get started. Today's presenter is Dr. Carey Melton, and Dr. Melton earned his PhD in Industrial Engineering and Management from Oklahoma State University in 2012 with a concentration in supply chain management and logistics. Since then, he's taught operations management, transportation strategies, inventory and forecasting analytics, engineering and business statistics, and goods and services at the undergraduate and graduate level at the University of Arkansas. He's been teaching online since 2015, and he joined the Arkansas faculty as an adjunct professor in 2013. He has industry experience working at J.B. Hunt Transport for 15 years and at Walmart for 6. He currently works for J.B. Hunt Transport in the corporate office in Lowell, Arkansas. So please, everyone, let's welcome Dr. Carey Melton on his Lunch and Learn webinar on truckload trucking fleet design and analytics. So Dr. Melton, welcome, and I will go ahead and pass the presentation on over to you.
Okay, great. Thank you, Karen. I appreciate it. Welcome everybody today to the series, and I'm going to go ahead. I'm just going to turn my video off for now. But like Karen said, I graduated from Oklahoma State University in Industrial Engineering and Management with my PhD, and taught various classes there for about a 4-year time period. I've been teaching adjunct at the University of Arkansas since 2013, various classes, and then been at J.B. Hunt, like Karen said, for 15 years. I am responsible for leading our engineering services division for the Northeast region of the United States. I've been leading that region, kind of that New York, New England area of the country for about 3 years now. So I've been with J.B. Hunt total for 15 years, 2 different stints. And then I was with Walmart for about 6 years. So again, welcome everyone. And what I want to do today is, I know we don't have a lot of time to get into a lot of detail, but what I want to discuss today is truckload trucking fleet design and analytics. Kind of talk about a little bit about what that means. So my focus today is going to be on transportation fleet design. I'll kind of go over what that means and how some different fleets are set up, and then also talk about data analytics. And the heavy part is going to be on fleet design. I will talk about data analytics and the importance of making sure that when you develop a fleet, it's in operation. We just have to make sure that we have the key metrics and key performance indices in place that are going to measure either the performance or underperformance of the fleet design. And so we'll look at a couple different dashboards as far as data analytics. I'll talk a little bit about Power BI and also Excel reporting. The heavy lift here is going to be on the transportation fleet design piece. So what I'll talk about first is transportation fleet design. Now, what is a transportation fleet design? Well, for a given customer, it's optimally determining how many trucks, drivers, and trailers are needed to operate a book of business for a time period. Now, the customer could be any customer. It could be a Walmart, it could be Amazon, it could be Target, it could be anything in retail, it could be outside of retail. So the customer really could be anyone. Also, the business could be really anything as well. It could be tied to a geographical region. It could be a group of stores, a group of distribution centers, a group of warehouses in a given area where deliveries are being made. Now, for the time period also is kind of wide open. It could be the time period could be we're developing a fleet for several weeks or several months. Typically, it's not that though. It's a fleet that's going to be set up to operate over typically over a 3 to 5 year period. So it's going to be over multiple years. But the kind of the average for a fleet design, especially here at JB Hunt, the average fleet is usually set up to operate anywhere from 3 to 5 years. Now, another thing that we're going to do with transportation fleet design is we want to make sure that our daily delivery routes are optimal or close to being optimal. We want to make sure that our fleet is set up so that the drivers have consistent routes daily for each week of the year. So we want to make sure that when we design a fleet, that both our trucks and our drivers are fully utilized. And I'll talk more about what a fully utilized driver is here in a minute. But one thing that we want to make sure of is that when we set up a fleet design, we want to make sure that our freight, our deliveries are consistent daily over 50 to 52 weeks a year. And then, like I mentioned, our drivers and trucks and trailers that are going to be dedicated, that are going to be designed, typically, like I said, it's going to be over a 3 to 5 year period, but it could be that a fleet is just going to be set up for several months or several weeks. That's kind of an outlier, but typically a fleet is set up to operate over multiple years. Now, this slide shows this is a fleet that we have in the northeast part of the U.S. The red dot there on the map represents a distribution center in Pennsylvania. The blue lines represent the different routes, the different deliveries that we're making to different states within the region. So we're making deliveries from the distribution center, that red dot, to different points, different stops in Pennsylvania, New Jersey, New York, Connecticut, Delaware. So with this fleet, you can see, I have noted up here that this activity here in the Northeast represents 15 drivers and 15 trucks and 60 trailers that have been designed to operate this activity 5 days a week, over 52 weeks a year. Now, the goal with this fleet, for this specific fleet, and then really for any design fleet, is we want to make sure that we have consistent daily and weekly routes for the drivers. We want to make sure that we're minimizing cost or distance. We want to make sure that we're adhering to hours of service rules that are mandated by the federal government. I'll talk a little bit more about what that means here in a minute. And then we want to make sure that the equipment, the trucks and trailers, and also the drivers are being fully utilized each day of the week, and then also each week of the year. Now, a fully utilized driver, it kind of depends on the business, but a fully utilized driver would be a driver that works about 40 to 55 hours each week. So if a driver is not fully utilized, a really poorly utilized driver would be a driver that only works 20 hours a week. So in a case like that, the driver could not make a living. So it would be a poor design if you had a driver that averaged only 20 hours a week. But so we want to make sure when we create this fleet that the driver is almost fully utilized. They're operating 40 to 50 hours, up to 55 hours each week. And then one kind of last thing is it's at the very bottom, but it's really the most important goal, is that we want to make sure that the fleet can operate safely. Now, the transportation fleet design could be really any kind of move from one point to another point. It could be that we're making multiple stops from a distribution center, delivering to multiple different stores within a region or within an area. Could be single stop deliveries from a warehouse or a distribution center to a store. It could be deliveries from suppliers to a distribution center. So it could be both inbound and outbound freight from to and from a distribution center. It could be cross dock or distribution deliveries. So it could involve a cross dock. It could be a port fulfillment center type delivery. And it could be a combination of all the different deliveries. So really when any type of move is being made and you're making delivery from one point to other points in a network, a transportation fleet can be set up to operate in a given area or in a given region. One thing that we want to make sure of, though, is that, I'd like to mention this several times, is that the stops need to be consistent each day of the week and each week of the year to make sure that the drivers and the equipment are fully utilized. Now, on this slide, kind of on the right hand side at the very bottom, this is an example of 3 different fleets that have been set up. You can see the different color coding. We have one fleet that has been set up for the Atlanta area, one for Jacksonville, Florida, one for Birmingham, Alabama. But you can see, for example, for Atlanta, we have a fleet there that's been designed and set up that they're making deliveries kind of in that central part of Georgia and then also into South Carolina. We also have a fleet there in Birmingham, Alabama that's been set up making deliveries into the panhandle of Florida and also into South and North Alabama. And then we have a Florida in Jacksonville, another fleet that's making deliveries in Florida and then also in the southern parts of Georgia. So that would be kind of 3 different fleets that have been set up in one region, but really 3 different areas of that region. Okay, some of the requirements to create a transportation fleet design. One thing that we have to have is historical delivery stop frequency data. So this would be shipment level data from an origin to delivery stop. So we want to make sure that we have data that we can use to create the fleet design. And so we want order level data or shipment level data. Kind of the ideal situation is we would want 3 to 12 months worth of data. Now, ideally, you would want 12 months worth of data because you can see any trends or any patterns, really any seasonality that's occurring during the year. And so the more data that we have, the better. So kind of ideally, we would want that 12 months worth of data. If you have the most current 3 months worth of data, that would work as well. It's current data. The only thing that would be missing there is that you would not be able to see really any trends or any seasonality that may be occurring throughout the year. So really when you design a fleet, the more data that you have, the better design that you can create. So we want shipment level or order level data. That's data from the origin to the different stops. Now a stop again can be a distribution center, it can be a fulfillment center, it can be a warehouse, can be a store, really could be anything that we deliver to. Now for the order level information for each stop, we want to make sure that we have the quantity being delivered to each stop. So that quantity could be in terms of pallets, the number of pallets being delivered. It could be in terms of weight, cubic feet, could be cases, cartons. Typically here at J.B. Hunt, it's going to be pallets, weight, or cubic feet. We have to have some kind of quantity for each delivery stop so that we know really what we're trying to optimize. And then for each stop, we need also information and delivery information and data about that stop for each stop. So we want to understand for each stop what the kind of the weekly and daily frequency looks like. How often do we deliver to that stop? Is it weekly? Is it daily? Is it only a few days a week? And so for each stop, we would want to know that information. We would also need to know what day of the week deliveries can be made on. And then also we would need to know what the delivery time windows are for each stop. For example, one stop could have a time delivery of 8 a.m. to 5 p.m. So we could deliver within that 8 a.m. to 5 p.m. time range. Other stops, though, could be may only have a 3-hour window. For example, 8 a.m. to 11 a.m. or 8 a.m. to 12 p.m. So we need to understand what days we can deliver on, and then what times that we can deliver on. Now, for each stop and then for each origin that's part of our data, we need to know where the location is. We need to know city, state, and zip code. So at the zip code level, we would need to know what the 5-digit zip code is. In an ideal situation, we would want to know what the address is, the physical address, but really with the information that we need to create a design, if we have the city, state, and the 5-digit zip code, then we can create a design based on that level of detail. Now, another thing that we need to understand is the trailing equipment that's going to be utilized. Is it 53-foot dry van trailers? Is it tanker trailers? Is it refrigerated trailers, flatbed trailers? So we need to know really what kind of equipment we're moving and what product we're moving. Now, another thing that's important down here at the bottom is the adherence to hours of service rules. I mentioned that a minute ago about federally mandated hours of service rules, but that's got to be part of the design. So those hours of service rules are incorporated in the design. So for example, if a driver drives 11 hours consecutively, that driver then must take a 10-hour break. Another rule would be if the driver works 14 hours consecutively. So maybe they drive and then they also do loading and unloading. If they work 14 consecutive hours, they also have to take a 10-hour break. So these different hours of service rules must be part of the transportation fleet design. Now this slide, what I'm showing here is just some examples of different trailers. Again, the trailing equipment that we're going to be using, very important because you've got to know what kind of product we're moving. In the top left-hand corner is just a 53-foot dry van trailer. That's kind of the most common trailer that you would see on the highway. Also below that is a refrigerated trailer, and I kind of broke the refrigerator apart from the trailer so that you can see what it looks like. That's another common trailer that you would see moving down the highway as well. Some other examples would be in the top in the middle, a tanker trailer, and then to the right of that, a flatbed trailer. At the bottom in the center is a live haul animal trailer. And then in the right bottom corner is a trailer with a lift gate. And you will see some of those. That lift gate is just used to both load and unload products. So that lift gate moves like an elevator. It moves product up and down, and so it makes it a little bit easier to unload the product. So those are some of the most common trailers that you would see moving on the highway. The most commonly trailers, again, that you would see that we use here at JB Hunt are the 53-foot dry van trailers, and then also the refrigerated trailers as well. Now, two different truck types that you'll see that are common. The truck on the left is a day cab truck. Now, the day cab trucks don't have a sleeper berth. So the day cabs are used for short distance routes. This would be where the driver is home on a daily basis. On the right-hand side is a sleeper cab truck. Now, the sleeper cab truck, I kind of indicated here in the picture, but it shows the sleeper berth. That would be where the driver would take a break or would sleep. But the sleeper cab is used for long distance routes where the driver is going to take a 10-hour break. You remember the 10-hour break that I talked about a minute ago? The driver would take that break in that sleeper berth, which is part of the truck. And so you can kind of see from the picture kind of the differences between the two different trucks. The one on the right, the sleeper cab, a little bit wider, a little bit bigger than the day cab truck. Now, if you have a case where the driver's in a day cab and for some reason you have to take a break, the only way a driver could take a break using a day cab would be in a hotel. And so the driver just wouldn't be able to take a break in the truck. But anyway, the day cabs are used for short distances. The sleeper cabs are used for long distance routes where you're going to have to take a 10-hour break. Now, I talked a little bit about data a minute ago, and data is really the key to a good design. Now, on this slide, what I want to do is read this slide kind of from the right to the left. So the first thing that we would want to determine is what our representative week would be to create a design. So what I did here in this right-hand table, I have the number of loads. This is for a specific customer, but I have the number of loads that we delivered for each week over a 7-month time period. So from January through July of this year, I have the load count that we delivered for each of the weeks. And the way I determined, you can determine this different ways, but one of the most common ways to determine a representative week is by looking at what the average week is. So in this set of data, the average week was at the very bottom, July the 24th of this year. So the average week was 120 loads. So that represents the representative or the average week for our data. So once I have that average week, then I convert that weekly data into daily data. And so you can see for that week, that July 24th week, I have 11 deliveries that I make on Sunday, 21 on Monday, and then you can see so forth. On Saturday, I have 6 deliveries. So you can see on Sunday and Saturday, I've had very few deliveries that are being made. But what I want to do is I want to break this. I've got my weekly data, I convert it to my daily data so that I can see how many deliveries that I'm making on each day of the week. And then from there, I'm going to go to the next slide. I convert that daily data into actual orders that are being delivered on each one of those days during that July the 24th week. So this table here at the very top shows the order level data that's being delivered on those different days of the week for that representative week. Now, I hid some of the columns, but in that first order at the top, order 137 in column A, that's going to be an order that's shipping from Philadelphia, Pennsylvania to Pottsville, Pennsylvania. Now the weight, you remember earlier I talked about pallets, weight, cubic feet. Here, the quantity that we're looking at is weight. So for this first order here, the weight that's being delivered is 31,425 pounds. And then that order is being delivered to on Monday, and it's going to be delivered between the hours of 7 a.m. and 5 p.m. That's my time delivery window. So you can see from the data, I have order level data. I have my origin, which is Philadelphia. My distribution center that I'm going to be delivering from is Philadelphia. And then I'm going to be delivering to multiple different cities within Pennsylvania, Connecticut, New Jersey, New York, and so forth. And then you can see the weight for each of the orders, the day that the delivery is going to be made, and then the delivery windows. So one thing that I didn't really spell out here is that for this activity, the maximum weight on a trailer is 45,000 pounds. And one of the things that we want to do when we create this optimal design, this fleet, is we want to make sure that we drive down miles and drive down transportation costs. So one thing that I noted here, I circled it here, but I have 2 different orders here that I could combine into one order or one route. So I have this 19,367 pound order. I have an 18,883 pound order. And if I combine those 2, it's going to be less than 45,000 pounds. My trailer can only, the maximum weight is 45,000 pounds for that trailer. So if I combine those 2 orders, I'm within that 45,000 pounds. And so I didn't just combine those to, just by looking at the weight. I also have to look at the day of the week that the orders are delivering on. And so I can see that both of these are delivering on Tuesday. So they have compatible delivery days. And then also they have compatible delivery windows. So I can deliver both of those orders on the same route. So in other words, I could combine those two orders on the same route. So when we're looking at the daily data for this representative week, what we're trying to do is create these optimal situations where we can combine different orders based on weight compatibility, the delivery day compatibility, and then we're going to make sure that we deliver within the delivery windows. But that's really kind of in a nutshell. We're trying to develop optimal routes by reducing the amount of miles or the amount of transportation costs that we have in the network. So this is kind of the level of data of detail that you would need to create your daily delivery routes for that representative week. Now, once we have our data, this data is going to be input into a software. Now, that software that I'll just go ahead and jump to it. Whoops. The software that I'm going to use for this example is Direct Route. Now, Direct Route is a routing software. And there's multiple different routing softwares that are out there on the market. We have 3 different routing tools that we have at JB Hunt that we use. For this example, though, I'm going to be referring to Direct Route. So when the data is obtained, so we had the weekly data, we converted it to daily data, and then we converted that to order level detail data. So once we have our order level detail data, then we can input that daily data for that representative week into the Direct Route software. So what's going to happen is, I'll show you what the data templates look like. But once we have our data, we've inputted our data into Direct Route. Direct Route is going to create optimal routes for each day of the week for that representative week. And then it's also going to determine how many trucks and drivers it's going to take on a daily basis to deliver to those different stops on the different routes for each day of the week. And then it's also going to show kind of a schedule each day of the week on the driver schedule, when they start and stop their schedule each day. And then it's also going to summarize, and I'll show you this here in a minute, some of the information, some of the activity that's really key to our transportation design. Now, this data may be a little bit difficult to read, but the top table, both of these tables are inputs to Direct Route. Now, the first table at the top, this is our stop level file from our order level detail data for each day of the week. So at the very top, that top data table, we're going to be making a delivery to Newburgh, New York. Now, if you look at that first row, the fixed time is 150. That means 150 minutes. So that stop is going to take 150 minutes. That delivery is going to take 150 minutes. We're going to be utilizing a 53-foot trailer. The weight for that delivery, the amount that we're going to be delivering is a little bit over 36,000 pounds. Our delivery window, this open one and close one, that's our time delivery window from 2 a.m. to 1800 or 6 p.m. And then pattern 1 represents the day that we're going to be delivering on. So that first order at the very top, we're going to be delivering on Monday. And so we can deliver on Monday anywhere from 2 a.m. to 1800 or 6 p.m. And so we have all of this table represents all the order level information and data. And so all of that would be an input into Direct Route. for each day of the week for that representative week. Now, another input table at the very bottom that we create is it's an input table to direct route. This would represent a truck file. So the software is going to optimally determine how many trucks and drivers that we need to operate the business, but we have to initially seed the software with X number of trucks. So that's what this bottom table represents. So one thing that you want to make sure of is that you have enough trucks in this bottom file to make all the deliveries in your top file. So you may seed your truck file with, let's say, 1,000 trucks, but it may only utilize 20 of those trucks. But you just want to make sure that you have enough trucks to make the deliveries in your top table in your stop file. So we have a stop file, our truck file, and you can see here in that bottom file, I'm only showing 17 different trucks, but you can see in column G, those trucks are going to be pulling 53-foot trailers. To the right of that, I've specified how much weight is going to be on that trailer. So each of these are 53-foot trailers. The maximum weight on those trailers are 45,000 pounds. Now over here to the far right, I've indicated where those trucks are going to be domiciled, where they're going to be located. So those trucks are going to be located in Philadelphia, Pennsylvania. So my distribution center that I operate out of is located in Philadelphia. So that's where the drivers and the trucks are going to be located. That's where they're going to start. They're going to start at the distribution center, then they're going to make deliveries to different stops in the network. The other thing that I wanted to point out is kind of in the middle here, it says maximum work time, maximum drive time. So those hours of service rules, I have to specify that in this table. So you remember my work time, my maximum amount of work time is 14 hours. So after 14 hours, the driver would take a 10-hour break. And then the maximum drive time, that was another hours of service rules, is 11 hours. So once a driver drives 11 hours consecutively, then they have to take a 10-hour break. So I want to make sure that I specify those hours of service rules in this table. That's one of the requirements. So once I have my input, those two input tables defined, then I can run my software and determine how many trucks, how many drivers going to be needed to make sure I deliver on each day of the week for that representative week. I'm going to kind of skip to the next slide, and then I'm going to skip back to this slide. So once direct route takes that input data and it creates an optimal fleet design, it creates optimal routes for each day of the week. This would be an example of an optimal route that it created. This is just one route of many. But this would be a route that begins in Philadelphia, Pennsylvania, makes a delivery in Allentown, Pennsylvania, Scranton, Pennsylvania, Hazleton Mills, Pennsylvania, and then the driver would drive back empty back to Philadelphia. So on this route, we have 3 different stops, and you can see that in the right-hand table. Over here on the left is just an illustration of what those stops would look like on a map. So this is just one example of a route that would be created by direct route using the data that we fed it, those based on those input tables. But you're going to have many routes for each day of the week. And so in the end, it's going to create a driver schedule. And so you can see from this data over here on the far left, I have driver 1, 2, 3, all the way down. I have my different driver numbers. So those represent individual drivers. And then to the right of that number is the work time and the drive time. And that's a weekly work time and a weekly drive time for the different drivers that were created based on the data that we inputted. And so you can see for Monday, Tuesday, Wednesday, Thursday, and Friday, the drivers are scheduled to work each day of the week. Now, one thing to note here is at the very bottom, driver 14 at the bottom only has 26 hours, roughly 27 hours of work time. And the reason for that is if you look on Wednesday, that driver does not have any activity on Wednesday. So that driver doesn't do anything on Wednesday. So, we want to make sure that the drivers are fully utilized, that 40 to 55 hours a week. And so you can see in this case, we have one driver that's not being fully utilized. And so they don't have any activity on Wednesday. And the reason why is for that representative week that we used, we only had a limited amount of delivery stop volume for Wednesday. But you can see for other days of the week, for all the drivers, they have pretty good work hours. They're being utilized each day of the week. So I'm going to skip back. So that would be the driver schedule. The output from Direct Route would show the driver schedule for each day of the week. It would also show the individual routes. And then in the end, it would create an overall summary of the activity. So it would show the weekly activity, and then it would also show the annual activity for the drivers. And so the weekly activity, it would break it down by total orders, total miles, stops, total number of drivers and trucks that are being utilized for that representative week for each day of that week. And then it would show the hours on average for each driver. So remember earlier I said a fully utilized driver, 40 to 55 hours. So in this design, the drivers are averaging about 50 hours a week. So that's really where we want to be. It's kind of optimal at that point. And then it breaks it down to annual statistics. But really the analyzed metric here is not really important. It's weekly is what we really want to focus on. The annualized statistics, the way the software does it, it just takes the weekly stats and then multiplies it by 52 to get an annualized view. Now, once we have our design, kind of the next step is to work with the customer to determine what key metrics or what key performance indices are critical to measure performance. And so that's where data analytics comes in. And a couple of different reporting mechanisms that we use that are commonly used, not just here at JB Hunt, but everywhere. A lot of reporting is really a lot is being done in Excel, but recently over the last couple of years, Power BI has been utilized to also report on different key metrics. But once we have our design completed, we want to make sure that we work closely with the customer to identify the key performance indices, the key performance metrics that are critical to the customer success. We want to make sure that those metrics are developed jointly between the transportation provider and also the customer. We want to make sure that we focus on key metrics that really drive the business, the success of the business. So we don't want to measure everything. We just want to measure key metrics that are important to the customer, that are important to driving business success. So once we have the metrics in place, we want to make sure that we have goals established for each metric. So we want to make sure that we work closely with the customer to develop these goals. Then we want to determine how to measure and report those different metrics, how the data will be stored, how the data will be queried, and then in the end, how will those metrics be reported? Will it be Excel? Will it be Power BI? Will it utilize some other mechanism? And then kind of lastly is we want to determine how often these metrics are updated and reported. Is it going to be something that's reported daily, weekly, could be multiple times throughout the day? So we want to make sure that we work with the customer to determine how often the metrics are updated and then reported as well. So the end in mind with the metrics is we want to compare actual activity to our goals. and we want to understand whether there's any gap between our performance and the goal. Now, if there's a situation where we're performing poorly, for a certain week or for a certain, maybe there's a trend of weeks, we want to do a root cause analysis to determine what's driving that behavior, what's driving that issue. And so really in transportation, there can be many buckets, but really the two buckets that are important typically to the transportation provider and to the customer are operational metrics and financial metrics. So many times the data is stored in DB2 tables, and then that data is queried using SQL or SQL, and then that data is reported up through either Excel or Power BI or both or some other mechanism. But the common metrics are operational metrics and financial metrics. Now, this is an example of operational metrics of Power BI dashboard. You can see here we have several different, 7 different metrics that we're reporting on. Up here in the top left-hand corner, we have miles per driver per week. And if you look at each one of these different metrics, we're reporting on a weekly basis. So that's our frequency of reporting. And then we also have a goal for each metric. So one thing that we want to make sure of is that we report at a certain frequency, but we want to make sure that we have a goal that's been established as well to compare to. So this would be some different operational metrics: miles per driver per week, loads per driver per week. And then you can see over here on the far right, on-time service is also a key metric. Now, and I only have a few examples of financial metrics that I used here, but these are 3 different financial metrics that are really important most of the time to different customers. Over here on the far left is the weekly cost. Kind of in the middle here is the cost per mile, and then on the far right is cost per load. So you can see for these different financial metrics, we're also reporting weekly, and then we also have a goal established for each of these 3 different metrics. So not only do we want to report weekly, or it could be daily, what the actual performance is, we also need to understand the goal and then understand the gap between the goal and the actual performance. So one way we go through, and let's say we have an issue with a customer, what we typically do is we go through this root cause analysis. And so over here in the far right, this is just a fishbone diagram, a cause-effect diagram. But over here on the far right, our main issue is that the customer is not satisfied. We have low customer satisfaction. Could be different reasons for that. I've outlined 3 different potential reasons. It could be because of high cost, could be poor on-time service, or it could be because of large stop time. Now, I further broke that down. So for poor on-time service, there could be different reasons for that. It could be due to truck maintenance issues, could be due to poor routing. There could be a lot of other reasons. Those are 2 really common reasons a lot of times for poor on-time service. High cost could be another reason, and then what's driving high cost, it could be a large customer stop time, it could be that it's a bad design, or it could be poor driver and equipment utilization. And then another big reason could be large stop time that's driving low customer satisfaction. And that could be because of, could be customer dock congestion. So there could be congestion that's prohibiting the driver from getting unloaded in a timely manner. Could be a lack of material handling equipment at the stop, or it could be that the trailer is poorly loaded, and so it takes a lot of time to unload that trailer. So really, once we have our design, we've gone through all of the data, we've created our design, kind of the next step is to develop the key metrics that are going to really help us determine if the fleet's successful or not. If we're having issues, then we need to go to this root cause analysis and kind of determine what's driving poor performance. So really with that being said, that's Karen, I'm ready for questions. That's all I have to present.
Okay, well, thank you so much for that presentation. That was very informative. I want to give everybody a chance, if you have any questions for Dr. Carrie Melton concerning the presentation that you just saw, please type those questions in the chat box. While we're waiting on any questions that you may have, I am going to briefly go over for our audience just our programs at a glance. We have a Master's in Science and Operations Management, as well as an MS in Engineering Management. Both are very similar, that they are offered 100% online, and in-state tuition is for everyone. Additional fees may apply for international students. They comprise of 10 graduate courses that equals 30 hours. There could be up to 4 undergraduate prereqs for the operations management degree, and possible prereqs for the engineering management. You would work individually with an advisor for that. There are 5 8-week sessions per year. There is no GRE or GMAT required for folks with a 3.0 or better with your undergraduate bachelor's. And the total program cost for both programs is anywhere between $12,000 and $15,000, so very affordable options here. And we also have 3 graduate certificates that I mentioned at the beginning of the hour. We have project management, designed to provide skills to become better project managers and prepare for the national PMP certification. We also have Lean Six Sigma, that you will learn how to eliminate problems, remove waste, and reduce variation to improve operations. And then finally, Homeland Security, which is designed for industry and safety professionals to learn how to mitigate risk. For those graduate certificates, there are only 4 classes, total of 12 credit hours. You can obtain this as part of your master's degree without taking any extra classes. Those classes will double count, or you could also take a certificate as a standalone program. The GPA requirement for our graduate certificates is 2.5 undergraduate GPA or better, with no GRE required. And it is an option for folks that are still maybe on the fence of committing to going for a full master's degree, that you could start the certificate, and it would also help you transition into a Master of Science program, whether that be the operations management or possibly the EM management, depending on the degree that you possess. So it looks like we had a few people drop off, but I don't see any questions in the chat box. With that, we are closing in to the 1 o'clock hour. But Dr. Melton, I just do have one question for you. You mentioned, I think, a lot of this, but how do you feel that this presentation would tie into your classes, or maybe the curriculum overall, into the operations management program?
Yeah, one thing that we do look a lot at is linear programming, and we look at the transportation model, which that linear programming, a lot of that ties into the optimization that we do, like using Direct Route or any of the other software packages. Kind of the nuts and bolts behind those different softwares are linear programming and other algorithms that tie very closely with some of the work that we do within the class.
Okay. So yes, we have someone on here. He says, hello. He says, I appreciate the assistance. How do you account for shortages in drivers or supply chain challenges, is his question. Oh, I'm sorry. That's from Dr. Rocky Gay. Thanks, Rocky, for joining us today.
Yeah, that's a really good question. And I think I meant to mention that a little bit earlier. We do have accounts for sometimes we have a lot of driver turnover for different reasoning. Turnover is different. It kind of depends on the economic kind of flavor of the country. But a lot of times what we do, within our dedicated contract services division, and then with other divisions within our company, if we're short drivers on an account, typically what we do is we will look at other accounts that are in close proximity to that account. And if we have drivers that need work for those other accounts, we'll move those over to that account. So any account that's short on drivers, we try to pull from other drivers within our kind of region, like in the Northeast region. And so we try to find accounts very close to that account that's needing drivers, and we'll share drivers between accounts.
Thank you very much. That is a great question.
That's a good question, because we had a lot of that back in COVID, back especially early on in March and April of last year. We had some accounts that completely closed down. It was just because of their type of business. And then we had other accounts where it was the food industry, and so the amount of volume had really exploded, and it was just, in some cases, just a substantial increase in volume. And so what we did, we moved a lot of those drivers from accounts that had closed into these other accounts where the volume had increased dramatically.
Yeah.
It's kind of easy to scale up and scale down in certain regions, especially in the Northeast, because there's a lot of the accounts are in close proximity to each other. But it can be troublesome in other areas because some accounts could be, far away from other accounts.
Right. No, that's great. So we seem to have a question regarding the emissions and operations management. That's fantastic. I actually have your email, so I will reach out to you independently after we wrap up, and we can have a discussion on admissions, if that's okay, since we're closing in on the hour. So Dr. Melton, I just want to thank you so much for your time. And I want to wish everybody a great winter break and happy holidays. And thank you for joining us today. Thank you, Dr. Melton.
Appreciate it. Thanks.